Think about the last time you typed a text message on your phone, and that little bar above the keyboard suggested the exact word you were about to use. AI models like ChatGPT work on that exact same principle. They play a mathematical game of guessing the very next word. The system reads your text, runs rapid math, and ranks the most logical next words based purely on their probability. It picks the winner, adds it to the sentence, and immediately runs the math again to figure out the word after that. This system operates as the ultimate autocomplete engine. How does a simple guessing machine learn the complex rules of human grammar? Developers feed the system an ocean of language. It reads billions of digitized books, articles, and websites to study the patterns of how we speak. This diagram shows the machine's internal structure, a neural network. Notice the web of connections linking the layers. The numbers on these connections are weights. Whenever the system guesses wrong during training, it tweaks these numerical weights to better match human language patterns. These panels illustrate the process. It takes millions of trial and error examples before the network begins to accurately mimic human language. Through brute force repetition, the AI mathematically models the underlying structure of language. Computers only speak in numbers. How can a machine grasp the meaning of an English word? To do this, it uses a method called embeddings. The system translates every word into a long list of numbers, which act like coordinates in a vast three-dimensional space. This scatter plot shows how the machine organizes language. It groups words from similar contexts together. Notice the clusters. Animals like dog and cat are mapped in one neighborhood, while fruit like apple and mango are kept distant on the right. This vast map of meaning allows a computer to navigate the nuances of human vocabulary without needing a brain. A basic phone keyboard usually loses the topic after 3 words. ChatGPT, however, manages to stay on track for entire essays. This technical flowchart outlines a breakthrough called the transformer architecture. It is the specific design that solved the AI's memory problem. The secret is a mechanism called attention. It prevents the AI from only looking at the very last word you typed. This attention mechanism acts like a backward-facing spotlight. While picking the next word, it actively scans previous paragraphs to remember the context. It scans earlier parts of the text to keep verbs aligned with their subjects and ensure pronouns point to the correct people. This attention spotlight enables the word guesser to sustain a deep, logical narrative. We have traced the journey from a phone predicting a single text to a massive network mapping the entirety of human language. Every time the AI writes, it combines its trained weights, its spatial maps, and its contextual spotlight to make a single guess. This wireframe visualizes that internal process. As it forms a sentence, the system traces a complex logical trajectory through its mathematical map. The resulting text feels human, but the output is driven entirely by these rigid mathematical rules. This technology functions as a mathematical mirror, reflecting the patterns of our own language back at us.